Okay, let's start with this. Here we have, now I think this is mechanics. So you are saying that you want to discuss the Newton laws of motion part, right?
Sorry, on second thoughts, would kinematics be okay? Yeah, kinematics.
Kinematics? Okay, good. Okay, so let's start with kinematics. Basically mechanics, right? It deals with everything about motion. When the body is in motion or the body is at rest. Now when I say the body is in motion, the first thing is what we can discuss is what part of the motion. When we discuss what part of the motion, it comes under kinematics.
Okay.
Fine? Comes under kinematics part.
Yeah.
When we talk about Y part, it comes under dynamics.
Okay.
So here we talk about why the body is why the body is moving, why the body is at rest, and all those.
Okay.
So let's start with kinematics. So in this, you know that whenever you'll be given some body, it can have two parts. One is it can be at motion or it can be at rest. We say the body is in motion when it changes its position with respect to the surrounding with time. Fine.
Yeah.
We say it is at rest when its position does not get changed with respect to its surroundings with time. So the position does not change.
Yeah.
See here, we can have a very example of, let's say there is a train which is moving. Fine.
Yeah.
In train, there are two people who are sitting next to each other, A and B. There is a third person C on the ground. Fine.
Yeah.
Now when this train is moving, what C will say that A is moving. Fine.
Yeah. Yeah.
Because train is moving.
Yeah.
But what B will say, who is sitting next to A, he will say that A is at rest.
Yeah.
Right? So the position of or the state of rest or the state of motion, it all depends on, with respect to the frame of reference which you are referring to.
Okay.
Now next is displacement and distance. So let's say there is a body here which is initially at this point and it has gone to point B. Now while going to point B, it is going like this and it has reached to point B like this. Whatever is the total length of this path, the total length of this path is called distance.
Yeah.
Right? But if you join point A with point B and you show it like a vector, this is called displacement. So displacement is nothing but the length of this line. But displacement is a vector quantity. I hope you know what are the vector and what are the scalar quantities.
Yeah.
Right?
Yeah.
Okay. So distance is a scalar quantity and it has as a unit of meters. Displacement has as a unit, it's a vector quantity and it is as a unit of meters. Right?
Yeah.
This is velocity.
Yeah.
Speed. See, when the body moves, it covers some distance with some rate.
Yeah.
So speed is nothing but the rate of change of distance with time.
Yeah.
This is called speed. Whereas the velocity is the rate of change of displacement with time. Right?
Yeah.
Distance So speed is a scalar quantity and it has the SI unit of meter per second. Velocity is a vector quantity. It has the SI unit of meter per second. Any doubt in here?
Yeah.
Mohammed?
No. No.
Now next is when we talk about average distance here. Average distance is, average speed is whatever is the total distance covered by the body by total time taken, right?
Yeah.
Here the key is the total distance covered. And we are not talking about the instantaneous speed. We are talking about the average speed. That is, let's say if you start from your home and you go to your school, the speed may start from 0, it may go to 100 and then may go to 40 and then may come down to 0 again.
Okay.
But when we talk about the average speed, we say, let's say if you are starting from your home and you are maintaining the constant speed throughout, then how much is that value?
Yeah.
That is the total distance by total time.
Yeah.
Similarly, we have the average velocity. It is equal to, have you completed this chapter in your school?
Yeah.
Okay, how many chapters have you completed?
Oh no, we did this in grade 9 and 10. I haven't started my IB yet. I start my IB next year.
Next year. Okay, I got it. When you say next year, it is 2020 or in 2019 starting from I think that must have started.
Yeah, IB first year starts in August 2019.
Okay, for you it's a 2019 August, right?
Yeah.
Okay. So this is what you have. Now next is acceleration. See, when the body moves, right?
Yeah.
Speed, the velocity changes. The rate of change of velocity with time is called acceleration. So acceleration A is change in velocity. Let's say v2 minus v1. Now this is a vector quantity. On vector quantity we put this arrow.
Yeah.
Right, v2 minus v1. And it's a vector quantity. The SI unit is meters per second square.
Yeah.
Right?
Yeah.
Now based on this, there are three equations of motion. So we write u as the initial velocity, v as the final velocity. So actually, I am covering it by assuming that you know the basics of all this. And so when I started this topic, I thought that you must have done this chapter in your school. But if some point, if you don't understand, do let me know. I will explain that to you.
Okay. Okay. I did it in grade 9 and 10.
Okay. Acceleration is the time. And next is the displacement. Now the equation which I am going to write, this is applicable for uniform accelerated motion.
Okay.
Uniform accelerated motion. It means the type of motion where acceleration A is constant. A is not changing with time.
Okay.
And A is nothing but acceleration. So acceleration is your, the rate at which the velocity is changing.
Yeah.
So you have the first equation. You know acceleration A is equal to change in velocity by time.
Yeah.
You have V is equal to U plus A. This is your first equation. Now if A is constant, okay, let me write that. This is called the first equation. Now the second equation is S, which is displacement, is equal to UT plus half AT square.
Yeah.
Make sure you take care of the direction. Why? Because these are the vector quantities.
Yeah.
Right? So if you are taking right side as positive, then the left side should be taken as negative.
Okay.
If you are taking upside as positive, then the downside should be taken as negative.
Okay.
Right?
Yeah.
Third is E square minus U square equal to 2AS. Right? Any doubt in this page?
No.
No.
No.